Finally, one question you may have is, how is ray tracing used in video games? There are many different methods, so we'll cover just a few of them. The first one is similar to path tracing, but with some shortcuts. For a given environment in a video game, a very low-resolution duplicate of all the models in the scene is created. Path tracing is then used to determine direct and indirect lighting for each of these low-resolution objects, and the results are saved into a light map on the low-resolution duplicate. Then the light map is applied to the high-resolution version of the objects in the scene, creating realistic indirect lighting and shadows on the high-resolution objects. This method is pretty good at approximating indirect lighting and is one of the ray tracing techniques used in Unreal Engine's Lumen Renderer. The second and completely different method for using ray tracing in video games is called screen space ray tracing. It doesn't use the scene's geometries, but rather uses the images and data generated from the video game graphics rendering pipeline, where all the objects in the scene undergo 3D transformations to build a flat 2D image on the view screen. During the video game graphics process, additional data is created, such as a depth map that shows how far each object and the corresponding pixels are from the camera, as well as a normal map that shows the direction each of the objects and pixels are facing. By combining the view screen, the depth map, and the normal map, we can generate an approximation for the X, Y, and Z values of the various objects in the scene, as well as determine what direction each pixel is facing. Now that we have a simplified scene, let's say this lake is reflective, and we want to know what pixels should be shown in its reflection. To figure it out, we use ray tracing with this simplified screen space 3D representation and bounce the rays off of the lake's pixels using the normal map. These rays then continue through the simplified geometry and hit the trees behind it, thus producing a reflection of the trees on the lake. One problematic issue with the screen space ray tracing is that it can only use the data that's on the screen. As a result, when the camera moves, the trees move out of view, and thus the trees are removed from the screen space data, and it's impossible to see them in the reflection. Additionally, screen space ray tracing doesn't allow for reflections of objects behind the camera.